All right, folks, it's good to see you again. We're going to attempt to get this video going here today. We're going to start Chapter 5. And Chapter 5 is an extension of Chapter 4. Chapter 4 was linear equations in two variables. And Chapter 5 is solving systems of linear equations. The key word in that title is systems. Here's what we mean by a system. A system is two or more linear equations that must contain the same variables. If they contain different variables, it's not a system. So this entire collection of two equations containing the same variables is called a system. Now, the objective of working with systems is to solve the system. And when we solve a system, the solution of every system is an ordered pair, an x value and a y value. The solution of a system is any ordered pair that must satisfy both equations. And what we mean by satisfy both equations, that given ordered pair must not only be a solution for the first equation, it must be a solution for the second one as well. So we're just going to begin off with a hypothetical ordered pair of 5, 2. And what we want to determine is this ordered pair 5, 2, does it satisfy both equations? Is it a solution of both? So what we do to determine, we take the x value of 5 and the y value of 2 and we substitute it in place of x and y in both equations. Let's do it to the first one and let's see what we get as a result when we do the mathematics on the left-hand side. 3 times the value of x, which is 5, then minus the value of y, which is 2. 15 minus 2 is 13. 13 equals 13. 5, 2 satisfies the first equation. Now it must satisfy the second one as well, so let's check it. 2 times the value of x, which is 5, plus the value of y, which is 2. 10 plus 2 is 12. 12 equals 12. 5 2's not only satisfies this equation, it satisfies the top one. That lets us know that the solution of this system is the ordered pair 5, 2, because 5, 2 satisfies both. It must satisfy both. Now, 5-1, 5-2, and 5-3 are going to concentrate on the different methods of how a system can be solved. 5-1 that we're going to look at today is the graphing method. Also today we'll look at 5-2, which is the substitution method, and 5-3, which is the elimination method that will involve addition. Graphing, substitution, and elimination. We're going to begin with the graphing method. And a key thing, folks, about solving a system by the graphing method. Let me get the materials out to your mind right now that are going to be critical that you use. Item number 1, to solve a system by the graphing method, you have to have graph paper. It will not work with lined paper. You have to have graph paper. So you're going to have to get it, unless you already have it. Item number 2, you want to make sure that you have a pencil that is sharpened as nicely as it can be sharpened. And number 3, you need to have a straight edge. It's not an option. You must have a straight edge. Either a student body card, a ruler, a charge card, any sort of a straight edge. Sharpened pencil, straight edge, and graph paper. You have to have it or it will not work. So, here's how the graphing method works for solving a system. I'm going to use this system as an example. I'm not going to do the graphing method for this one, but I'm going to use this one as an example. The graphing method is this. You take each one of the equations that make up the system, and you graph each one of the equations on the same coordinate plane. On the same coordinate plane. Now, you just took an exam, and on that exam that you took, you had to graph a linear equation in two different ways. The x and y intercept method and the slope y-intercept method. Y is equal to mx plus b. So when we use the graphing method to solve a system, you graph each one of these equations on the same coordinate plane. And to graph each one of them, you're going to make a decision. You're either going to decide that you're going to use the x and y intercept method to graph, or you're going to use the slope and the y-intercept to graph. You can stay with one method over the other for all the problems that you do. But as you're going to see when we demonstrate today, we're going to see that from time to time, the x and y intercept method is a nice method to use. And with another equation, the slope and the y-intercept would be maybe the more advisable way to go. So, we're going to start with problem number 1. Here's the first one that we're going to do. There's the system up there in blue. 2x plus y is equal to 6. 2x minus y is equal to negative 2. I want you to look at both of these equations. They are both written in standard form. And when they are written in standard form, that ordinarily opens up the door to using the x and y intercept method for graphing. And that is what we're going to do with number 1. There's another reason why we're going to use the t-charts and the x and y intercepts to graph both of these. Look at equation number 1 and look at the constant term. Here's how you can tell if your x and y intercepts are going to be very nice values. No fractions, no decimals. Take your constant term and mentally divide the constant term by the coefficients of y and x. 6 divided by the coefficient of y here, which is 1. 6 divided by 1 divides evenly. 6 divided by 2 divides evenly. If we use the intercepts for equation number 1, we're going to get nice points. Look at equation number 2. Look at the constant term. Negative 2 is evenly divisible by the coefficient of y here, negative 1. Negative 2 divided by negative 1 is a positive 2, goes evenly. Negative 2 divided by a positive 2 goes evenly. That's something that I would look at in terms of picking the way that you're going to do it. So we're going to do number 1. And when we do number 1, I'm going to use the x and y intercept method. Here's the t-chart for number 1. Here's the t-chart for number 2. Now I'm going to try to keep myself out of the way from the camera and everything here. We're going to find the x-intercept first. Let y be equal to 0. If you come up here to equation number 1 and you just imagine that there's a 0 there. People, you cover it up like we've done over and over again. Cover it up, solve that resulting equation for x. 2x is equal to 6. 6 must be divided by 2. That's 3. Let's find the y-intercept. Let x be equal to 0. 2 times 0, nothing. Cover it up, You can see what y is. It's staring right at you. Y is 6. Now let him rest. We'll come back to him. Let's go to number 2. Let y be equal to 0. 0 there. Cover it up. Solve that equation for x. You got to divide negative 2 by 2. Negative 1. Let x be 0. Now we're going to have to be careful here. Watch out for the signs. If x is 0, 0 times 2, nothing. You are left with this. A negative 1y is equal to negative 2. You got to divide negative 2 by negative 1. That's a positive 2. We have our values. Now we come over to the coordinate plane. Let's start with the facts for equation 1 and let's plot. 3, 0. Start at the origin. X is 3. 1, 2, 3. And y is 0. There's your x-intercept. 0, 6. X is 0. Going to have to come up 6. 1, 2, 3, 4, 5, 6. Y-intercept, x-intercept. Now we take that straight edge. And here is a key thing. You'll want to remember this. When we make this line through those intercept points, you want to make that line long enough. Don't make that line too short, because we've got another set of points that we're going to have to plot on this same coordinate plane. And if those two lines are going to intersect, we want to make sure that we've made the lines long enough so that they will intersect. So now it's up to me to come and line up that y-intercept up there with this x-intercept. And what you want to try and do, you have to use a straight edge. And when you have got it so well lined up, make it long enough. Cover enough quadrant space. Now I'm just going to kind of leave it like that. Hopefully that will be sufficient enough. Now we go to the second. Negative 1, 0. Start at the compass. X is negative 1, y is 0. Go to the left. There's the negative 1, 0. 0, 2. X is 0, up 2. We line up these 2 points. And people, I can already see that line is going to intersect at a very identifiable point. Now, it's hard for you to see it on YouTube because you can't see those lines, but we connect. Make them intersect. Make sure you make them intersect. You don't have to keep going up. They've intersected. I'll put an arrow there and an arrow there. Now, the graphing is done. Now we have to identify the solution. The solution is the ordered pair that is represented by the point of intersection. These 2 graphs intersect at this point. That's the solution. We need to name it. That point is in quadrant 1. Quadrant 1 is positive, positive. Let's find the solution. Start at the origin. X is 1. Yeah, X is 1. And y, go up. 1, 2, 3, 4. The solution to this system is 1, 4. If you substitute the x value of 1 and the y value of 4 in place of x and y in both of these equations, you're going to get a value of 6 on the left-hand side, which will match him. And for this second equation, you're going to get a value of negative 2 that's going to match him. I'm not going to take the time to check it. It is a good-looking answer. Now, you're looking at the most common thing that needs to be done. Now, before I leave this, let me tell you some of the mistakes that students will make. Mistake number one, they do all of this beautifully. They get their graphs beautifully done. They intersect, but then they leave it and they go to the next problem. You can't leave it. You've got to identify the solution. The second thing that happens, people sometimes do not make the lines long enough to the point that they need to intersect. They don't make them long enough. They just kind of connect these two, but they don't keep it going up. You got to keep it going up until it intersects, if it is going to intersect. And 99% of the time, the lines are going to intersect. One other thing that you're not going to have to be concerned about. You will not ever be given a situation to where the two lines, let me just do it right here. You will never be given a situation where the two lines are going to intersect somewhere in the white. That's not going to happen. We won't let that happen because it would be too difficult to identify the solution. You can go to the bank on this. The lines will always intersect at the corner points of the little grids on your graph paper. Now that's number one. Number two, here's the system. Notice standard form. Let's make just sort of a look at equation number one, and let's see what our intercepts are going to look like. Just do a little test. The constant term 4 is evenly divisible by -2, so that intercept will be nice. The constant term of 4 is evenly divisible by 1, the coefficient of x. Since 4 is evenly divisible by both the coefficients of x and y, I would use the x and y intercept method, and I've got it ready right here when I'm going to do it in a moment. But look at number 2. Not that we couldn't use the x and y intercepts. Let's check the divisions. The constant term 3 is evenly divisible by the coefficient of 1 here. 3 divided by 1 is 3. Works out evenly. But the constant term 3 is not evenly divisible by the coefficient of x. 3 divided by 2 is not an integer. It's a decimal. It's a fraction. It's 1.5. It's 1.5. Now there's nothing wrong with that. But let's consider doing the following to number 2 when we do it. Let's consider solving it for y and getting it in slope-intercept form. Why will it be so nice? Because the coefficient of y is already 1. Okay? You're going to get a nice little equation. So here we go. I'm going to start with number 1. So I do the x and y intercepts. Y is 0. -2 times 0 is 0. Cover it up. People, you can see right now what x is. It's 4. Turn it around. If x is 0, cover it up. Solve this equation for y. 4 divided by -2, -2. Got that. Put it on hold. Now let's go to equation number 2. And I'm going to elect to get it in slope-intercept form. Let's solve it for y. He's got to go. Opposite. -2x. -2x. Y is equal to a -2x positive 3. Your slope is -2, and we will write it as the ratio of rise to run. -2 over 1. You'll always put it over 1 if the slope is an integer value. -2 over 1. There's the rise. 1 will be the run. In your y-intercept, the x value is always 0. And your b, your y value, there he is, positive 3. There's that data. Now let's plot. Let's start with number 1. You can start with him, doesn't matter. Let's start with him. 4, 0. 1, 2, 3, 4. Y is 0. It's going to stay right there. 0, negative 2. X is 0, down 2. 1, 2. Y-intercept, X-intercept. Line those guys up as well as you can. And make the line long enough, because you don't know where the other one is going to intersect it. Now let's go to this. When we graph an equation using the slope and the y-intercept, you always begin by plotting the y-intercept. You can't rise negative 2 if you don't have a beginning. You got to plot the y-intercept first. 0, 3. X is 0, up 3. 1, 2, 3. And then beginning right there, we're going to rise negative 2, and we're going to run a positive 1. Rise a negative 2, we're going to go down 2. Go down to 1, 2, and then run it positive 1. And that would be right there. Now here's an advantage that you can do when you're using the slope and the y-intercept. You can stop right there, and you can connect them. And they're going to go through a very identifiable point. But notice what you can also do. Let's begin at this second point that we just got after we rose down 2 and ran 1. Begin there. Go down 2 again. 1, 2, and run it 1, and you are smack dab right on that line. That's going to be the intersecting point. Line those puppies up. Connect. Make sure it goes through. Put arrows on each end. You have graphed both equations on the same coordinate plane. Now we identify the solution. You have to. Start at the origin. X is 1, 2. X is 2. 1, 2, down 1. X is 2, y is negative 1. There would be the solution for that system. I'm not going to check it. It will work. I'm going to get rid of this sheet. We're going to come down, we're going to do this number 3. I told you we would do one that would have no solution. I want you to see it. Look at equation number 1. It's in standard. Let's check our little division moves. 2 is evenly divisible by the coefficient of 1. 2 is evenly divisible by 2. I'll go ahead and use the x and y intercepts for him. This one, let's check it. 9 is evenly divisible by 3. 9 is not evenly divisible by 6. Now, does that mean that you can't use the x and y intercept? Not at all. But I'm going to go ahead and use the slope y-intercept for this as well, just so that you can see it again. Let's go to number 1. If y is 0, cover it up. 2x is equal to 2. Divide both sides by 2. 1. Let x be 0. 0 times 2, nothing. It's telling you right there that y is 2. Let's go over here. You wanted to use the intercepts? It'll work beautifully. We're going to solve this for y. Negative 6x. Negative 6x. 3y is equal to a negative 6x plus 9. Over 3, over 3 over 3. Y is equal to a negative 2x positive 3. Your slope, a negative 2 over 1. Your y-intercept, 0, 3. Let's plot. Let's go to here. 1, 0. 0, 2. X is 0, up 2. Be safe. Line it up. Don't be in such a rush. You want to make sure that that line goes through the hearts of those points. Make it long enough. Here. Plot the y-intercept. 0, 3. X is 0, up 3. 1, 2. Rise of negative 2, run of positive 1. Start at this y-intercept of 0, 3. Go down 2. Negative 2 down. Negative 1, negative 2, run at 1. Run at 1. Do it again. Go down 2. 1, 2, run at 1. There's 3 points. Now, it certainly doesn't give us the idea that they are going to intersect, and they're not. They never touch. It's what I pointed out before. They're parallel. There can't be a solution. The lines don't touch. So here's the way that we would like you to do it. One of two things. Don't leave it that way, because I'll just come back on your paper and say, what's the solution? You didn't give me the solution. The solution is there is no solution. And you can do one of two things. This is what most instructors will instruct. The symbol for the empty set. Folks, that's not 0. That's the empty set. You can either do that, or you can simply write no solution. Now there's the graphing method. We've done 3 of them for you. Now when we reunite, we'll move into 5.2 and take care of substitution. See you in a bit. Thanks.